First one, when you do this, you're usually doing this like in a pre-algebra or algebra class. You're looking for a pattern. And so you say, okay, the x values, these are what I'm putting into the function. And the y values, that's what's coming out. So if you just look at it here, you can see, I'm going from 7 to 4, 8 outputs 5, 9 outputs 6, and 10 outputs 7. So by looking at it, you can see that we're actually subtracting 3. 7 minus 3 is 4, 8 minus 3 is 5, 9 minus 3 is 6, and 10 minus 3 is 7. So we can see that our equation or our function is y equals x, which is our input, minus 3, and that gives us our y value, our output. So x is what we're putting in, and we're taking away 3, and we get y as our output, okay? This one's kind of easy, but we'll get to some a little more challenging ones here. So number 2, what you can see here is it's a little bit trickier to tell what's happening. Like 6, out comes 17, 7's the input, 20 comes out, 8, 23, 9, 26. We might not see a pattern right away, but what you can do with these problems is you can look at what is happening to go from one y value to the next y value, okay? So here you can see I'm adding 3 to get from 17 to 20. I'm adding 3 again to get from 20 to 23, and I'm adding 3 again to get from 23 to 26. So you can see that's consistent, right? And we can see that with the x values, I keep going up by 1, and up by 1. So it looks like for every increase in 1 on the x, okay, the 3 is going up, the y is going up by 3, right? So what we can do is we can say, it looks like what I'm doing is I'm tripling the input, okay? I'm multiplying the input times 3, but we have to make a little bit of an adjustment. So let's look at this. 6 times 3 is 18, but you can see our output is 17. 7 times 3 is 21, but again, this is 20. 8 times 3 is 24, this is 23. You can see we have to make an adjustment. We have to subtract 1. So this is going to be the equation that represents, this input-output table. So again, what you do is you look at the change in y over the change in x. So you make a fraction, and that's giving you what's called the slope or the rate of change. But at this level, when they usually present these input-output tables, you haven't gotten yet to this equation that you'll be learning in a little bit, which is the y equals mx plus b. So at this stage, they're just trying to help you to understand, how to recognize these patterns. Okay, the last one, number 3, that I've written here is, again, you can see what's happening is we're going up by 1 again, up by 1 again. And with the x values, we're going up by 2 this time. See, 4 to 6, 6 to 8. And so here we can see that the change in y is an increase of 1 for every change in x, which is an increase in 2. So what we have here is we have y equals 1/2 x. So 1/2 times our input. Now you can see here 1/2 times 2 is 1, but we're getting 7. 1/2 times 4 is 2, but we're getting 8. So it looks like we have to adjust that by adding 6 more. Okay, so this is what's called our y-intercept or our initial condition. And this is what the value is when x is 0. So 0 is like the starting point. But I think for this video, and just to kind of help you to get started with these input-output tables, is look at how the y's are changing, look how the x's are changing, and write a fraction, the change in y over the change in x. Put that number in front of the x value, which is the input, and then test it out and see what adjustment you have to make. Do you have to subtract 1, add 6, so that it represents the input-output table. So again, this is just an introduction about how to write rules for functions given an input-output table. I've been working with some students lately in like pre-algebra, algebra, and they haven't really gotten yet into the slope-intercept form. If you want to learn more about this, I'll have a link for a video that I did on slope-intercept form so you can learn more. I'll see you in the next video.